Thanks, Alison. And yeah, good to see so many people here today. I'm Mikey van Mourik. I'm a senior hydrogeologist at Tamrock Energy, and I'm going to talk today and present on the operational findings and lessons learned from the Lanchester Wines mine water geothermal heating scheme, which David mentioned earlier. So I'm going to begin by just giving a background on the two schemes that exist at Lanchester Wines, and then I'm going to talk about some of the challenges that were inherited by Tamrock Energy when we took over operation in 2021, and then I'll move on and talk about some of the kind of lessons learned and mitigations that we used to deal with those challenges. But first of all, just to give an introduction to Tamrock Energy for those that don't know. So we're a technical consultancy established in 2013 to help develop commercial geothermal heating projects in the UK, now abroad as well. We're based in Edinburgh, and over the last decade, we've built several first-of-the-kind projects, including the two, now operating, the only two privately funded mine water geothermal heating schemes in the UK, which is the Lanchester Wines project that this talk is about. So to start off with a background on Lanchester Wines, as David mentioned, there are two different schemes, both owned by Lanchester Wines. There's Nest Road to the northwest in this image, and Abbotsford Road to the southeast. Both were operational in 2018, which is when they started. And as you can see, Abbotsford Road has got twice the installed heat capacity as Nest Road. They're about 600 meters apart, and both are tapping into the same kind of larger mine units. So to give you an overview on the setup for both of these schemes. So I'll start with Abbotsford Road on the left, and as you can see, there are three main aquifer units. At the top, there's an upper aquifer system, which is made of is a sandstone aquifer, and then there are two mined aquifer units below that. So there's the high main aquifer, which has the high main seam, and the deep mine aquifer, which is made up of the Rastill, Hutton, and Harvey Beaumont seams. So the Abbotsford Road site has one abstraction borehole and two injection boreholes. The abstraction borehole in red, ABO4, is drilled to 265 meters and abstracts water at 19 degrees Celsius. It then extracts delta T of 8 degrees from that water before it's injected back into the high main aquifer at 11 degrees Celsius. Nest Road is essentially a mirror of that system, so it abstracts water from the high main seam, a cooler temperature of 14 degrees, and then re-injects it back into the deep mine aquifer system at 10 degrees Celsius. So it has a delta T of 4. And so that's kind of the overview of how both of these systems work. The rest of the talk, I'm going to focus on Abbotsford Road and the challenges that were kind of inherited there, because Nest Road is essentially brilliant and works really well. It also only requires one abstraction and one injection well, as shown here. To give you a bit of context about what the plant room looks like for an operational system. So on the left, you have the plate heat exchanger, which allows the heat exchange between the extracted water from the mines and the internal kind of heat network in the warehouse that's being heated. And on the right, you have the two 1.2 megawatt heat pumps that raise that mine temperature from 19 degrees up to about 50 degrees before it kind of gets circulated for space heating. And you can see there's a picture of the warehouse itself and all the wine being stored there. And I'm now going to talk about some of the challenges that were inherited when Tamrock took over operation in 2021. So the main challenges were an over-design of the plant and the kind of installed capacity being higher than the flow rate could provide, an unfavorable water chemistry, there being a high concentration of iron, and the previous regulatory landscape back in 2021 when this system was inherited. And just for context, you can see on the right there a picture of the buffer tank, which is where the kind of heated water is stored before it's circulated around the warehouse. So I'm going to go through each of these challenges in order. So to begin with, this is the original design of the system back in 2021. And as you can see, there are three abstraction boreholes on the right and three injection boreholes at the bottom there. The abstraction boreholes were originally extracting from the sandstone for that upper aquifer system I showed before. And there was basically an overestimation of how much flow that would provide. So there was a pumping test performed on one borehole, and it was assumed that you get 3 times that. But in reality, because the boreholes interact with one another, that flow rate was in practice lower, and there wasn't enough flow to kind of provide the full kind of capacity for the design system. So only one abstraction and 2 discharge boreholes were ever used at one time. And this made an inefficient heating system. So that was the first challenge. Unfavorable water chemistry. So you can see from these pictures that there was large iron ochre buildup, and that's because the abstraction boreholes taking water out of the upper aquifer system had a moderate iron concentration, but it was an oxidizing system. So that iron was oxidized and precipitated in the water. So you can see on the left, the plate heat exchanger, which is about to be cleaned, should be nice and shiny, and it's instead got a lot of iron ochre buildup, and that reduces the amount of heat exchange that can happen between the mine water and the kind of circulating water. And on the right, you have the impellers that were in the pipework from the abstraction borehole to the plate heat exchanger, and you can see how much iron ochre has clogged them up and reduced the flow that can actually get through. So all of this together kind of created quite an inefficient flow system. And then finally, the previous regulatory landscape. So there are 2 main regulatory stakeholders involved in mine water heating in the UK, well, in England at least, the Environment Agency and the Mining Remediation Authority. So back in 2021, the regulation landscape was in its infancy because this is the first kind of multi-megawatt heating system. And a lot of the kind of regulations were set up more for regular groundwater abstraction rather than specifically for mine water abstraction. The heat access agreement, which is basically the agreement by which you can access these mines and extract heat, was also in its infancy. That's since been developed, which I'll come on to later. But also the timing of these 2 regulatory processes and how they interacted was challenging. We're trying to fit that in with the heating season being in the winter and kind of all the kind of works that we need to be performed having to be done in a narrow window in the summer. So moving on to the mitigations of how Tamrock solves some of these challenges. The first one, which is what David talked about earlier, which Geothermal involved in, was drilling a new abstraction borehole into the deep mine aquifer system down to 265 meters. And that was a very successful drilling program. We got a really good borehole out of it. And one of the 2 kind of key things happened as a result of that. We were able to get warmer water, which allowed kind of a higher delta T to be taken out and a higher capacity. And also the deep down mine aquifer system was a reducing environment, which meant that although it had higher iron concentration, it was not oxidized and so remained in solution and didn't precipitate and cause iron ochre buildup. As you can see the picture of the ABO4 mine water here, which is quite nice and clean. The system itself, the heat pump and the plant room, were reconfigured to be able to extract these higher temperatures and get a higher delta T out of it, and optimize the kind of working pressures and temperatures to create a more efficient system and a higher capacity. And then finally, streamlining of the regulations. So since Tamrock has been involved since 2021, along with Lanchester Wines, we have worked in collaboration with the Mining Remediation Authority and the Environment Agency to streamline the regulatory processes and kind of make them more fit for purpose and kind of more make sure that they're sufficient, both the regulatory side of the coin and the operational side of the coin are content with how everything is operating. And the result of this was to develop a new heat access agreement, which now kind of, both sides are happy with and is for purpose and is specific to mine water heating in general. And it's worth pointing out that Lanchester Wines self-funded the legal kind of requirements to get to this stage, and have been a pioneer in kind of developing this regulatory process for other heating schemes across the UK, and they've kind of set a precedent for how to do that. So there's still work to be done, and there's still kind of things to be ironed out in terms of regulatory processes. which Tamrock are very happy to be involved in and kind of work with these stakeholders to kind of iron out that process and make it as streamlined as possible. And some of those are kind of regulatory timelines and processing times, etc. So finally, just kind of finishing with some key takeaways. You can see the core that was removed from the drilling program in 2022. But a good conceptual hydrogeological understanding helps to design the most efficient project possible, but it also encourages engagement with the stakeholders of the regulatory side as well, because they can have confidence that you understand the mine system as well, and that everyone is on the same page and satisfied that the data coming back is sufficient for making sure the environment is protected. And then finally, an innovative mindset and awareness of best practice is key when you're dealing with some of the inevitable challenges that are going to arise, because however well you design something on paper, when you put it into practice, there are going to be things that you didn't know were going to happen and challenges that arise that need to be dealt with. So the more malleable you can be in your approach to that, the easier you're going to have, easier time you're going to have in being able to deal with those challenges. So that's it from me. Thanks for listening, and let's give you a whistle-stop tour of the Lanchester Wines site.